paper, right? You need to practice. In exam, I may ask different questions. Ma'am, haven't practiced such questions like that. Okay, so you have to practice by yourself. Now, let me begin today's class. Yesterday, what we have seen two types of finite automata with output, which are milli and mole. Now, today, what we're going to see is we're going to learn how to convert from milli to mole and then from mole to milli. Okay, so let me start the first one. So in textbook, if you go back and then read the textbook, you'll find many theoretical stuff need to be read by you guys. So that part you have to do, it has to be done by you guys. Okay. So as per the theorem or as per the context of that textbook, right? They are saying that milli and mole are equivalent in nature. Whatever the language which could be accepted or which could be represented or which could be produced by milli can be done the same way in Moore machine. Okay. The diagram which could be represented for these two machine, right? It might be different, but conceptually they are almost equivalent. Okay. So now first one is I'm going to convert a given Moore machine to a milli machine. And I need not remind you guys how to represent a Moore machine or milli machine like that. Okay. Today I'm just considering you guys have done your part, you have studied yesterday evening itself, and then I'll be considering in that way, and I'll be continuing the class like that. So let me draw the Moore machine. Q1, 1. Purposely, I'm drawing the state in a bigger way because we are representing the output value inside the state itself. Okay. So whenever a Moore machine or milli machine is provided to you, you have to check the completeness what we used to do in the case of DFA. Okay. This is a textbook. I mean, this is a ready-made example. So I guess this is a complete DFA with output. Now, how to convert a Moore machine to milli means in the case of milli, right? What we have seen yesterday is every input. I don't want to allow Chaitanya. Okay, every input, right, will have a corresponding output. Every input will have a corresponding output in the case of milli, but in the case of Moore, every state has its own output value associated with each state. So that is the major difference between Moore and milli. So how am I supposed to convert this Moore to milli means the initial state will remain the same. The initial state will remain the same. So in this case, right, let me begin with initial state. Now see here how to start converting from Moore to milli means I need to scan this state individually. I need to scan the state individually, and then every state will be having an outgoing age as well as incoming age. So the important part is we need to check the incoming arc in a particular state. So first let me consider Q naught. What about Q naught? Is there any incoming age? No incoming. I'll just write no incoming. No incoming. Okay. Now next one is, let me go for Q1. In the case of Q1, right, any incoming age is there, and any incoming arc is there? Yes. Let me write one incoming. One incoming. And then what I'm going to modify is, I'm going to start modifying this Q1 part. So this Q1, right, let me remove the output associated with it. And one incoming is there from Q naught part. I won't mention, I won't Q naught here. Q naught. Then A1. 1 means Q0 to have one incoming art towards Q1 with input symbol A, and then the corresponding output values attached with the state Q1 is 1. So this one will be, designated here. Okay, A by this one. This is the way of converting Moore to milli. Now this is not yet completed. Now next one is I'm going to scan Q2. Next one is I'm going to scan Q2. In Q2, how many incoming arcs are there? 3. Then the self loop also you need to count. So 3 incoming, 3 incoming. So I need to modify it here. Let me modify it. I'm going to remove the output associated with this state Q2. So I've kept this one as Q2 as it is. And then this one will be A0 will be the corresponding output with this input A. And then B with input 0, output 0, and then B with output 0. Okay, this is Q2. Now next one is Q3. If suppose in exam, if I provide you with a DFA with output consisting of 10 states, you have to scan all the states. Okay, the states are easy, but the time might be a little bit consuming if the number of states keeps on increasing. Now, what about Q3? How many incoming 8s are there? 3 are there. 3 are there with 4 input values. So this one also I'm going to modify it. So let me just say 3 incoming. 3 incoming, and then so you should not write like this in exam. Okay, read properly what are the terms, what are the, like you should write it properly, like there are no incoming arcs in this, there are 1 incoming arcs with A as the input symbol, or here also there are 3 incoming arcs with A comma B comma A as the input. Like that you have to write it in a very brief way in exam. Okay, now this one is for Q3. So Q3, right, what I'm going to do is I'm going to remove the associated output from Q3 and then AB. Now this one is B, this one is A. Then what about the self loop? A comma B. The self loop A comma B. And the output associated with this Q3 is 1. Hence, let me modify this incoming arc as like this. Okay, so every state I have scanned it and then somehow I have modified it. Now I'm going to modify the whole diagram in milli machine. So let me just bring a copy of this one down. Okay, and let me draw a smaller version of it. This is the given Moore. Oh, sorry. This is the given Moore machine and then the required milli. The required milli machine, let me just draw it. Here, what I need to do is whatever modification I have done there, right? I need to replace in here. This is Q1. This is Q2. The initial state won't change. The initial state will remain the same, both for milli to Moore or Moore to milli. Q3. This is A by 1 because 1 is associated with this Q1. Once you understand the concept, right, by seeing the machine itself, you can easily convert from Moore to milli. Now for B, 0 is the associated output for this particular state Q2. Hence, let me combine 0 here. And then for this input A, for this input value A, right, 0 is the associated output values for this Q2. Hence, let me put A with this. And then what about Q2 to Q3 arc? B by 1 because 1 is the associated output values for Q3. And then from this to this, A is the input symbol. 1 is associated with Q3, hence let me write 1 here. And then for Q3 self loop, right, we have first input symbol as output 1. B, second one. Oh, sorry, what happened? Then B1. Then what about this Q1 to Q2? Q1 to Q2, B, then the associated output for this Q2 is 0, hence B associated with 0. Any other arc or incoming stuff being left out? No. So this is the required milli machine for the given Moore machine. Okay. This is the required milli machine. And then yesterday itself, I have just informed you guys for machine also, I'm going to use a short term notation M/C, but please avoid this things in exam. Okay. I'm using it for my class. So this is the first example for converting a Moore machine to milli machine. Now next one is we are going to check out for a given milli to Moore machine. We are going to check out how to convert a milli machine to Moore machine. So for this one, right, let me just write the title. Milli machine to Moore machine. Milli machine to Moore machine. So let me just draw the diagram. Q1, Q3, Q2, Q naught, I can't allow. Now see here, this is the given milli machine, and then our target is to convert this milli to Moore. Okay. And then as per the common thing which I have just said in the case of Moore to milli, the initial states will remain the same. Okay. So now in here also I'm going to scan the incoming arc for each and every state, and I'll be doing like that. Okay. Now first one is, this is not complex. Okay, do not think that everything is complex. Once you understand, it's not that complex. So first one, I'm going to consider Q naught. In the case of Q naught, right? In the case of Q naught, see here, this is first incoming arc. This is second. Okay. Now I'll be using different color. Now, first first input symbol, I'm considering what I'm seeing right now, right, is associated with 0 as the output. And then the second incoming with incoming arc with input symbol B is associated with output 1. But one thing is that every state, right, we cannot write that it is associated with 0, comma 1, comma 2, like that. Okay, every state will have an associated output values. So now for this Q naught, two incoming arcs are there with two different output. So what we are going to do is we are going to split Q naught into two. So in my case, I'll be splitting Q naught like this, which will be indicating the 0 as the output values. And then let me represent Q naught this, which is associated with 1 as the output values. Okay, so now let me just initiate the Moore machine. Now there will be two initial state. This one will be a little bit So this is zero will be associated, 1 will be associated with this. And then told that the initial state will be same. But for this one, right, we have split it, the initial state into two. But we cannot have an initial state more than one. Okay, this is the concept which we have studied at the beginning of the finite automata. So it's up to you whether you want to choose this one. Let me tell. You want to choose this one as the initial state or this one as the initial state. It's up to you. So let me just choose this arbitrarily as the initial state. It's up to you. If you're going to choose this one as initial state, nothing wrong in that one. But only one initial state has to be there. From the splitted part, of the initial state, you have to choose either one state as the initial state. Now see here, this is Q1. This is Q1. From Q1 to one incoming arc towards the Q0 0, and then for the input symbol A. And then from Q3, there will be one incoming arc with B as the input. Any other incoming things? No. What about the outgoing part? The outgoing part, there are two. What about the outgoing part? There are two. There are two means from Q0 to Q2, and then from Q0 to Q3. Right now, what I'm doing is I'm just considering the input incoming arc. Okay, so everything we need to split. Now, one of you just unmute your mic. Till now, it is understandable or not how I have split it and how I have chosen the initial state. Till now, I'm not talking about the, let me just call this as first step or something. Okay, let me name like this. So one of you just unmute your mic and tell me whether it's understandable or not.
Yes, ma'am, it's understandable.
Okay, thank you. Now next part is, let me just bring this down, a copy of it. Okay. So first one I have done for the incoming part. What about the outgoing part? There are two. So this is regarding the, sorry, this is regarding the incoming part. Okay. And then what about the outgoing arc? Outgoing arc. What about the outgoing arc? It's there. Q0 to Q2 and then Q0 to Q3. Q0 to Q2, Q0 to Q3. Now what we are going to do is we have split it Q0 into two states. So now let me just draw a state here, Q2, Q0, I mean, this one is part of this one is part of this. So from both the divided state, we are going to draw an arc towards Q2 with input symbol A. Got it? From Q0 to Q2, one outgoing arc is there with input symbol A and then output 1. So what I have done here is from this to this A input symbol, from this to this A input symbol. What about the output? This we don't know yet. So let me just write 1 here. Let me just write 1 here. This is a mixture right now. Okay, this is a mixture right now. This is not a complete one. We are in the progress of converting a milli to more. That's why this is not correct. But for our understanding purpose, I'm doing like this. Okay, this is not a correct format. In a particular mix both milli and more. We are in the progress of converting a given milli machine towards a more machine. and then we have decided what will be the output with this Q2. Hence, I have associated with this one output. Again, this input A is associated with this one output. Okay. Now, next one is from Q0 to Q3, there is an outgoing arc with input symbol B. So from this to right, we'll be doing the same. From this to B with this. Again, Q2, Q3 also, we haven't decided what will be the output associated with this one. That's why from both Q2 divided parts, we are doing like this. Okay. Now, next one is, oh, sorry. Let me just bring the updated one, or else it will take lots of time for me. Let me bring the same. Okay. So Q not completed. Q not completed. This one, let me just call it as two. Let me term this as two. Now, in this case, right, let me start thinking about Q1. Let me start thinking about Q1. What about Q1? Now, let me go back to the original state provided to us. Q1, how many incoming arcs are there? Two. Q1, how many incoming arcs are there? Two. In this, what are the incoming arc? B associated with one output, A associated with one output. Out of these two, right? Out of these two, let me just consider this one first. And then when before considering this one first, the output associated with both the incomings are same, that is 1. Hence, Q1, right? We are going to associate the state Q1 with 1 as the output, 1 as the output value. Okay, because from the output of a state is being indicated, is being retrieved from the incoming arc. So Q1 got 2 incoming arc. For this 2 incoming, the output values are same. Hence, Q1 is being associated with 1 as the output symbol. Now, what about the incoming arc? How to solve that one? So I'm going to consider this B, this one. So instead of B associating with this one, I'll be just B. Let me just use black color. That will be better. This will be associated with 1. This will be B. And then what about A? This is from Q2 to Q1. From Q2 to Q1, this is A. Okay. So no, what about the outgoing, this one? What about the outgoing arc? Yes, from Q1 to Q0. Whether it's already there? Yes. Whether it's already there? Yes. So no need to consider much for this Q1. Now the same diagram, this is the second one. Let me just copy paste it somewhere else. For your understanding only, I'm doing the step by step separately, okay? Else, because I've done the same manner. This one. Q1 completed. Next one is 3. I'm going to check out for Q2. I'm going to check out for Q2. Now let me go back to the original provided machine. What about this Q2? In the case of Q2, right? Uh-oh. In the case of Q2, how many? This one, this. Out of the arc, check the output value associated with them. This one is 1, this one is 0, this one is 0. So what we have done in the case of Q naught, right? We are going to split this Q2 into two parts. One is going to denote the output. One state will be associating the output value 0. Another one will be associating with output value 1. So now what I'm going to do is I'm going to split. I'm going to split here, and then again same thing. I'll take one like this. One state will be associated with 0. Another state will be associated with 1. Okay, this is regarding Q2. So now what I need to do is, let me just be in order to avoid our error rates, right? So I'll just do one thing. This. Oh, let me keep this one as it is. The same one, let me bring down because I don't have much space here. I'm going to split it here. So this 3, right? Again, this will be 3, but let me just redraw it. Okay, that way we'll avoid the error. Now this Q2 will be of two parts. Q2, 0. And then another one is Q2, 1. So in here, right, how many incoming arc? 1, 2, 3. 3 are there. So out of these 3, right, this one, the one associated with 1, is the incoming from Q0 to Q2. Q0 to Q2 with A as the input symbol. Q0 to Q2 with A as the input symbol is associated with 1. Q0 to Q2, stay here. Let me Q0 to Q2. Wait a second. Okay, fine. So this one, right? Let me take this two. These two incoming arc towards Q2 are having the input symbol as A, and then the output symbol associated with this are 1. So what we're going to do is, instead of pointing this incoming arc from Q node divided parts towards the Q2, right, we'll be pointing them towards this. So now let me draw it. This is Q naught 0, 0. This is Q naught 1, 1. So now what I'm going to do is, both are associated with 1. Both are associated with 1, hence this. Both are associated with 1, hence this. And then this is the initial state. And then what else? This is going to be Q1, 1, B. This is A. And then this is going to be Q3, B. Something went wrong here. What is that? Okay, B by this. B by this. This is a mixture. Okay, right now we are in the progress of converting milli to mu. That's why we are mixing everything. Anything is missing around here? No, I guess. Okay. from this original I have solved this A by one I have solved. Now what about remaining this one? Remaining incoming arc from Q3 towards Q2, right? From Q3 towards Q2, this is the arc, and then the output associated with this one is 0. Hence, what I need to do is from Q3 to from Q3 to this with A, because the output associated with this one is 0, hence Q3 to the splitted part of Q2 with output 0. And then what about the self loop B? The self loop B, right, it associated with output 0. Hence, what I need to do is this will be marked here, B. Then any other arc being left out is here. Okay. Now from Q2 to Q1. From Q2 to Q1, there is one common arc from Q2 towards Q1. Now Q2 has been splitted. Now Q2 has been splitted. So from both the splitted states, right, we'll have an outgoing arc towards Q1 with input A from both these splitted Q2. Okay, no incoming or outgoing arcs will be left out when you're converting it to another state, one state to another. Now Q0, Q1, Q2 completed. Next one is going to be battery low. Now next one is going to be Q3. Now this is this same diagram, right? Let me just mark it as 3A, or else stay B, the final one for step number 3, because this started from here and then it ended here. Now next one is Q3. Now Q3, let me bring this final one. For Q3, let me bring the final one. Okay. Now next, this is going to be 4. This is going to be 4. And then we are going to consider Q3. We are going to consider Q3. What about Q3? Let's go back to the original one. How many incoming arcs are there? Only one. Only one. Only one. With input symbol B, and then output associated with this one is 0. Hence what will happen for Q3, right? For Q3, the output associated will be 0. Now see here, when I compare the original one, right? And then when I compare the original one with this one, we have two incoming arc. Why? Because we are in the progress of converting one machine to another. So many splitting of states happen. So from those splitting states, right, we might have occur extra incoming arc also. Hence, originally for Q3, there were only one single incoming arc from Q0 to Q3. Q0 has been splitted, hence 2 incoming arc towards Q3 right now. So these are the 2 cases. Now for both the input incoming arc, right, the output associated is 0 value. 0 value, both are same. So what we're going to do is the output will be 0, and then instead of this, you'll have B alone. Okay, this one also, let me just use black color. 0. This is the required what was okay. It might be, but once you understand, right, it's not that lengthy. done this. Let me just summarize a bit, okay? Don't get confused, whatever I've just done till now. What we have done is, this is Q0, this is Q1, A was there. If suppose you have splitted this into two, if suppose you have splitted this into two, like Q0 this, then Q0 this, then what will happen is, just 2 minutes. What will happen is, from both the splitted states, right? You need to mark like this. This is the concept we have been using till this far, from step number 1 till step number 4. Okay, there are many examples in the textbook. Please go through by yourself. So thank you. This is the end of this class. And then who was there? I mean, Sweta or somebody, you got some doubts regarding the construction or something?